Okay, so here's chapter 4 review. You might want to watch this before the test, but I'm going to go over, this is in your textbook, a lot of this stuff. So page 245 is where we're going to start here. And I would encourage you in every chapter to read through the skills summary, to do lots of review questions from the review assignment. It's good to help you prepare for a test. So I'll just run over this real quick. In section 4.1 and 4.2, what we did was we classified numbers. We talked about what rational numbers were. Rational numbers are numbers that can be written as a ratio of two integers, okay? And what you want to focus on for rational numbers, right, is repeating or terminating decimals are rational. So 2 is just a regular old terminating decimal. Terminating means it stops, okay? 3.75, it stops after the 5, okay? If it repeats, like 0.01 repeating, that is also a rational number, can be written as a ratio of two integers, and any fraction that you see obviously is a ratio of integers. An irrational number is a non-repeating or non-terminating decimal. If you plug it in on your calculator, you'll see a whole bunch of different numbers, and the decimal will apparently fill up your whole screen. So examples are root 3 and pi, okay? Pi is the most famous irrational number, probably. All right, again, if you have questions about your hand, I'm just going to run through this kind of quick because it's a review. 4.3, we talked about radicals, and radicals have some kind of root sign, right? If there's no number inside the root sign, then it's a square root. That's a typical, your most common root. This is a cubed root because it has a 3 there. And again, I'll zoom in just a smidge here. So what we've been able to do is to write radicals. We've been able to simplify a root. And so if you have a square root of 200, to simplify this means we want to look for factors of 200 underneath the root sign that are perfect squares. And so if you can write 200 as a product, that's multiplication of two numbers, where one is a perfect square, then that's awesome. That helps us to simplify. So if you notice here, 200 can be written as 100 times 2. And this 100, actually, the root sign can be separated to both factors. And so root 100 is just plain old 10. So here's how we've simplified root 200. It's actually 10 root 2. Okay? Now, if you, the other thing is we want to choose the largest perfect square factor if you can. If you choose one that's smaller, you might have to just do this twice or 3 times, okay? Which is not the end of the world. Like, for example, if I said, oh, this is 25 times 8, okay? 200 is 25 times 8. No problem. This is a perfect square, so that's going to be 5 root 8. Now, I wouldn't be done yet because 8 also has a perfect square factor, right? So you always have to double check to make sure you got the biggest one. And this is not a problem. It just adds an extra couple steps. So this is actually root 4 times 2 inside there. And root 4 is actually 2. So this is 5 times 2. And then the root 2 has to stay there because that can't be simplified. And that's where you get your 10 root 2. So it's not impossible if you chose the wrong perfect square factor, but you just might have to, be an extra couple steps. Now the same goes for cube roots or fourth roots. Cube roots are most common. If you have cube root of 200, you're going to want to find a factor of 200 that is a perfect cube. And here is where we would choose 8 as a perfect cube, okay? Because 8, is 2 times 2 times 2. So the cube root of 8 can be simplified to just plain old 2 right there. And then the cube root of 25 cannot be simplified any further, so we write that over there. And this is our final answer. So again, if you see a 3 there, you're looking for a perfect cube factor. If you see nothing here, you're looking for a perfect square factor. And that's how you simplify. Okay? So those are 2 common ones. And yeah, you'll need to memorize, you should try and memorize your perfect square numbers probably up to, up to 20 squared probably would be nice. That would help you do your homework a little bit quicker. So everything from 2 squared, 3 squared, 4 squared, all the way to 18 squared, 19 squared, 200 squared, or 20 squared, sorry, not 200 squared. That's not hard, but. So up to there, if you try and memorize those, that would be good for you. And then the perfect cubes, probably up to 10 cubed would be good. So if you can memorize up to, 8 cubed, 9 cubed, 10 cubed. If you can memorize those, that would be great. Okay, so let's see, section 4.4 and 5. Evaluating powers. So we talked about fractional exponents, so where exponents are fractions. We talked about negative exponents in these sections as well. So if you had something like this, if you had 64 to the power of negative 2/3, couple things going on here. This negative exponent means that this whole power should be taken down to the denominator to become a positive exponent. And that's probably a good first step to do whenever you see a negative exponent. And so this brings it down to the denominator, makes that negative exponent a positive exponent. The second part is the number in the bottom of the fraction there, that's the index for the root, right? So that means it's a cubed root. And then the number on top is just a regular exponent. So 64 to the power of 2/3 is actually the cubed root of 64 all squared. And this is also true, you could do cubed root of 64 with the squared underneath that radical sign. That works as well. But this is usually tougher because this is a huge number. So trying to find the cube root of a really, really large number is tougher than trying to find the cube root of a smaller number. So usually if you take the cube root first, then square it afterwards, that's easiest. Okay? So the cube root of 64 is actually 4, because 4 times 4 is 16, times another 4 is 64. There's your 3 4s. So this is 1 over 4 squared, which is 1 over 16. So this is a perfect question that you will have to know how to do without a calculator on the quiz and on the exam. Prepare to do all this stuff without a calculator. Like I said, that's why I want you to try and memorize some perfect squares and stuff. Okay, any questions there? Okay, so if you have a negative exponent, probably best to write that as a positive exponent in your answer. So for example, if your answer was 4 to the negative 3, or let's say 4 to the negative 2, you would probably write that as 1 over 4 squared, which would be 1 over 16, okay? So you wouldn't leave this as your final answer because it's got a negative exponent. Technically, that's not simplified. The mathematical convention says that you probably should turn that into a positive exponent, okay? Which is easy to do. So don't circle this one. You go ahead and you would evaluate it all the way down to this, okay? Okay. And finally, just in our summary here, this is the 4.61 where we're basically combining everything together, all the exponent laws. We looked at the exponent laws, we're combining them all together. So for a crazy question like this, right? Crazy question like this, probably what you want to do is try and simplify things inside the brackets first. And as you remember, you want to do the numerator and the denominator kind of separately. And if you can simplify things inside the brackets, that's a good idea to do first. So xy squared to the power of 3 is x cubed times y to the 2 times 3, y to the 6. Down here, you can't really do any simplification, so we'll just rewrite everything here. Now, you have options here next. You have options. One option is to apply this exponent, whatever it is, positive, negative, whatever, to the top and the bottom separately. You could do that first, or you could do what they have done here in this example, and they used this negative exponent to flip everything inside the brackets, okay? So I don't know which one you like better, but this negative exponent means that the top and the bottom can switch places, okay? And then that exponent becomes positive. So notice how x to the 5 y is up at top now, and x cubed y to the 6 is now in the bottom, okay? So that's one way you could do it as well. So now what you do is you apply the 4 exponent to the top and to the bottom, and then you would do this. So x to the 5 times 4, right? Oh, what did they do here? Oh, okay, so they did not do this next. You could, but you don't have to. What they did was they worked inside the brackets and they simplified inside the brackets first. Okay, so let's do it that way. But you do have options. I wouldn't normally do it that way, but you have options. Totally fine, totally fine. So what they did was they focused on inside the brackets simplifying, let's say like this, x to the 5 divided by x to the 3 becomes x squared. You see that? And then they focused on y to the 1 divided by y to the 6, which is 1 minus 6 is negative 5, and that's where you get this part. Okay? So they worked inside the brackets and simplified this first to get this right here. Which is valid. That's valid. You might like that too. I don't know. Doesn't matter. Now they're going to apply the exponent now outside the brackets there. So this 4 now is multiplied by 2 to get 8. And this 4 is multiplied by negative 5 to get negative 20. Okay? And then finally, if you have a negative exponent, make that a positive exponent by moving things to the denominator. And so you have x to the 8 over y to the 20, and that's your final answer there. So that would be probably the most complicated question that you would get, something like that, right? Is there's lots of little steps all at once. You're using a lot of the exponent laws at once, and so that would be this, and this is from 4.6, right? So this is the last section you did. That's why you're working so hard on 4.6, I know. So simplest expression using positive exponents there, they tell you that right there. Okay? So now what I'd like to do is a few examples for you from your review assignment. So I'm actually going to do some of your homework with you here, if you don't mind. Okay? I'll do some of your homework with you. I won't do everything, but I'll just do sample questions. So this is, in your review assignment, this is review number 1. Okay? Your review assignment. So it says evaluate each radical. Remember what evaluate means? Did I tell you about this? Do you remember what evaluate means? Yeah. It means what? Not solve. It's different than solve. Solve means find the unknown value for the variable, which there's no variables in here. Evaluate means find a number answer. That's what evaluate means. So give me the simplest number answer. Number answer. So yeah, we're not simplifying. Simplifying is just like, you know, applying kind of rules to make a whole bunch of complicated stuff one simple thing. Evaluate goes a step further and says give me a number answer. Okay? Excuse me. So the cube root of 1,000, you have multiple options. You may have this memorized already. That's great. But what you would want to identify is, can I write 1,000 as a perfect square or a perfect cube number? And of course, this is 10 cubed, right? It's 10 times 10 times 10. So because you have 3 of these, the perfect cube is 10. It's 10 cubed. So the answer is just 10. And that's something that you could have memorized. No problem. If we move over to B here now, so I'll write this a little bit bigger. Root 0.81. Okay. What you would notice is that, hey, 81 is a perfect square. You know that one, right? What is it? What squared is 81? Okay. 9 squared is 81. The other part, the decimal part, can be a little tricky, but you have 2 decimal places here. Okay? Shh, quiet. You have 2 decimal places here. So what you're looking for is a number when multiplied by itself gives you 0.81. Now, 9 is not going to work, right? 9 squared is 81. But because it's a decimal, you might want to try 0.9. Now, 9 times 9 is 81. And remember the multiplication rules with decimals. If you have 1 decimal and you multiply by another number with 1 decimal, the answer has 2 decimal places. So does that look like the number we're looking for? Yes, it does. So our number is 0.9. Okay? Another way to look at this is, you're asking yourself if this is reasonable. You would say, is 0.81, is that 90% of 90? Right? You're taking 90%. It's like 0.9 times 0.9. Is 90% of 0.9 81? Yeah. If you had 0.81, if that was, or if you had a test, right, and you got 90% and the total marks were 0.9, that would be just under 0.9, which would be about 81, right? 0.81. So however you want to rational, you know, that in your mind. But count the decimal places, yeah. And in order for this to work, a little hint, the number of decimal places has to be even. Okay, if it's an odd number of decimal places, you're hooped. Not for a square root, okay? Has to be even number of decimal places. All right, the 6th root of 64. Oh my, the 6th root of 64. Huh. So this is like 64 to the 1/6, right? Or I'm looking for a number when multiplied by itself 6 times gives me 64. Is that even possible? What's the smallest number you think might work? Okay, let's try 2. Okay, that's 3. Here's 4, 5, and 6. Now, this is 4 times 4 times 4. Ooh. 4 times 4 times 4 is 64. Or what about this? 8 times 8. You see that? That's 8, and this is 8. 8 times 8. Cool. So, my answer is 2. The 6th root of 64 is 2. Okay, just for time's sake, I'm going to move on to another type of number of question. Identify the number in each case. So 5 is the square root of a number. Okay, so 5 equals the square root of x. Now this is stuff you can do in your head, right? Square root, cube root, you know this. What's the number? Yeah, it's 25, right? The other thing to note is that, remember when we were talking about the square root club? Okay? If 5 is the answer, if 5 wanted to get into the square root club, what would 5 have to become? It would have to become 5 squared. Remember that lesson? Get into the square root club? It's kicking inside the square root club. But in order to get inside the square root club, a regular old number here would have to get squared. So root 25 is 5. So this answer is, the number is x equals 25, or just 25. Okay? What about B? 6 is the cube root of a number, so 6 equals cube root of something. I don't know what this is. If 6 wanted to get into the cube root club, what would it have to do? Get cubed. What's 6 cubed? Huh. 16. It's I know what 6 squared is 36, right? So what's 36 times 6? Let's see, that's 6 times 6 is 36. 6 times 3 is 18, plus 3 is 21. Does that look right? Yeah. 216, is that what you said? Nice. So the number is 216. So the cube root of 216 is 6. Because 6 squared times 6 is 216. Or 6 cubed. All right, I'm going through this pretty quick because it's a review. So you guys are all looking okay? Okay? All right, let's keep moving. I think I've got 1, 2, 3, 4. I got a bunch of questions left, so we'll just keep going here. You mind if I just do some more of your homework for you? Is that okay? You're all right with that? Okay. I'll just keep going. Number 6. I'm skipping around a little bit. But I'll do number 6 with you. Okay. Tell whether each number is rational or irrational. Oh, that's easy. We remember the review there. A rational number has a decimal that terminates or is repeating, right? So in this question, you can just look at a lot of these and you can say you know whether it's rational or irrational. -2 is a decimal that terminates, right? It's 2. It stops right there. Now, is it a decimal? Well, it's kind of like 2.0, right? You can write it as a decimal. 2 is a rational number. The other thing is, can you write -2 as a ratio of integers? Yeah. There's 2 integers, that's the same as -2, right? So -2 is rational. Okay, what about 17? Ooh, 17, that's a prime number, it's odd, but is it rational? Can you write this as a ratio of 2 integers? You can. I'm thinking of this one. Or I'm thinking of this one. Does that make sense? Yeah. So yes, ratio, it's rational, okay? What about root 16? Ooh, square root there. It might be irrational, right? Except that this simplifies to plain old 4, which is rational. So these are all rational, okay? What about root 32? Is 32 a perfect square? No. If I simplified this, I could go root 16 times root 2, which is 4 root 2. So because I have a square root 2 in the answer, that means it's irrational, because I cannot simplify this radical. That is irrational. Now, on your calculator, if you had a calculator, you could plug in root 32, which I will do to show you how you could check this. If my calculator decides to wake up and be alive. Do, 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 do. Arise from the dead. Amen. Amen. I might have 2 calculators because I actually hit it twice. Look at it, I have 2 calculators. Wow, unnecessary. Hey. Okay, so check it out. What does this look like? What does this look like if I do root 32 on clear square root 32? Look at that. It's a big long decimal. That's as many decimals as I can fit on this calculator, so that means it's full. And there's no number that repeats, or a section of numbers that repeats. So again, if you have a section of numbers, 2 or 3 or 4 digits that repeat, blocks of them, rational. But this is no repeating, no ending, irrational. Got it? Also, root 2 is in the simplified answer. That's irrational. Okay, 0.756. Is this a rational or irrational number? Rational, why? Why would you say that?
Because it terminates.
It's a decimal that terminates. Thank you. Yes. And you also can write it as 756 over 1,000. Right? That's what that means. Okay. This one, it does not terminate, but does it repeat? 12.3 repeating, right? So on, so on. So is that rational if it repeats?
Yeah.
Rational. Okay, good. So rational, rational, irrational. All right. Moving on. Okay, this one's easy. This one's easy. It looks hard. Word problem. Ooh, scary word problem. Ooh, freak out. No, you don't have to freak out. Read it carefully, okay? These word problems are not hard because they give you the formula and they tell you what to plug into the formula, and all you have to do is evaluate, okay? So the formula t equals 2 pi root L over 9.8 gives the time, that's t, in seconds, wonderful, for one complete swing of a pendulum, like if you have a pendulum clock, okay? The time it takes for one complete swing given the length of the pendulum in meters. So it's basically describing what this formula represents, okay? Now here we go. A clock has a pendulum that is 0.25 meters long. That's 25 centimeters long. It's swinging like this, okay? What time does the pendulum take to complete one swing? Give the answer to the nearest second. Okay. So all you do is plug this length in for L. And then solve, evaluate, right? Solve, you can solve for t. Solve is okay. But you evaluate this side of the expression, you solve for t. And then just round your answer to the nearest second. So yes, you can use your calculator on this one, no big deal. This is what you're actually doing. 2 pi times the square root of 0.25 over 9.8. Now, we want to double check one thing. This is the only thing that makes this tricky. The length has to be in meters. If you're going to plug a number in, the length has to be in meters. Is this length given in meters? Yes. The one tricky part that I may throw on a test for you, because I'm just that kind of guy. I want to trick you. Except I'm telling you about it, so I'm not tricking you. But let's say that this was 0.25 centimeters. Can you just plug 0.25 into your formula? No. You have to convert it first to meters. So you have to make sure your units line up. Okay? So if I said 25 centimeters, you would have to say, hey, wait a minute, this formula only takes meters. I need to convert that to meters, which I know that there's 100 centimeters in a meter, 0.25 meters. That's the number you put in. So there might be an added wrinkle to a question where you have to make sure that you're putting in the right number into the formula, but that's as tough as it gets, okay? So, and that applies to math, science, everything moving forward. You got to make sure, and this is what I call it, you got to make sure your units line up. So if the units, the number that you're putting in, the units have to line up with the formula. If they match, then you just plug it in and you're good to go. Was there a hand up back there? You got a quick question?
Let's say like this formula comes up. Would you need like a calculator for it?
Yes, exactly. You're going to need a calculator for this one.
Well, you said I'm not going to like use a calculator for the test.
Right, so you might not have a question exactly like this on your quiz. Yeah, okay? But guess what? I could pretty easily give you a number that is really easy to simplify in here, and then you would have to do that, right? So, yeah, I mean, you need to know how to do this. So this is a calculator type situation. So let me do that real quick for you. Okay, so 2 pi, let me just clear this. 2 pi. Now, you have to be careful here because this is the square root of this whole thing here. So times the square root, so you don't have to put times, you can just do square root. If you just line up like this, your calculator assumes you're multiplying everything. And then make sure that inside these brackets you put 0.25 divided by 9.8. Okay, the whole thing inside the root. And let's see, 1.0035. Now it's to the nearest what? Second. So that's the nearest whole number. So the answer is t equals 1 second. Done. Easy peasy. Alrighty? Okay. The final two types of questions here for you today. Write each radical in simplest form. So that's going to be the number 11 there. I'll put this down here maybe. All right. So 11a, root 150. Root 150. So I'm looking for a factor of 150 that's a perfect square. Can you think of any? 25. Okay, good. 25 times what? 25 times 6. Okay, so root 25, I can simplify. Root 6 can't simplify. So this is 5 root 6. I like it. Double check to see that 6 is not a perfect square, or that 6 doesn't have a factor that's a perfect square, and it doesn't, right? Only 1, 2, 3, and 6 are factors of 6. No perfect squares in that list, so you're done. Does that look good? B, cube root. Okay, B. So I'm looking for a perfect cube that's a factor of 135. Can I find one? Let's see. 135 divided by, what are my perfect cubes? 8. Can I do 135 divided by 8? Does that go evenly? Or what's the next one? 27. What's the one after that? 64. What do you think? 27? Well, let's see. 27 times 2 is what? 54. Add another 27 would be 81, right? That's 3. So this is 3 cubed. This is 3 to the 4. This is 3.
27 times 5.
Sorry?
27 times 5.
Okay, so if we keep going here, 27, oh, I'm looking for, okay. So this is 27 times 1 times 2 times 3. Add another 27, that's 108, right? That's 108. Add another 27, oh, is that 135? 27, that is. So this is, yeah, this is 27 times 1, 2, 3, 4, 5. Awesome. 27 times 5. So that you could do without a calculator. It might take you a few extra seconds. If you did have a calculator for this on a test or quiz or your assignment, then you would just simply take 135, divide it by some perfect cubes, and see what you get. So you'd get 27 times 5. So cube root of 27 is 3. Cube root of 5 is unsimplifiable, so you just write that like that. Capiche? Okay. I will leave the last two for you to do. We're running out of time in this class, so I'll just do maybe one more. I don't know if I'll do this one for you today. That one of those. Write each mixed radical as an entire radical. So again, with this one, what you want to do is the number, in order to get into a square root club, has to get squared. So this 6 to get inside here has to go, the 5 I'll leave there. The 6 has to be now a 36. You see that? So what's 5 times 36? Well, you could do this by hand if you want. That's 30. 5 times 3 is 15. 180. So this is root 180. Okay, let's do this one. D. The fourth root club. What do you think this poor little 2 would have to do to get into the fourth root club? It would have to get fourthed. It's fourth to get in there. I'm fourthed. Okay. They're fourthing me. Okay, so 2 to the 4. You see? That little 2 right here has to become a 2 to the 4 to get in there. And of course, this guy's already in there, so he doesn't have to change. So what does this become? What's 2 to the 4? 16. 2 times 16. That is the fourth root of 32? Good? All right, what's that time? Oh, I think I got time. I got time. Let me do one of these. Okay, this is 4.6, right? Which one do you want to do?
You have 3 minutes.
The hardest.
I don't know what. Okay.
D.
You know what? These A, B, and D are all easy because they have the same bases, guys. All you do is subtract the exponents here. Subtract the exponents. Add the exponents.
C.
Let's do C. Okay, look at.
You have 2 minutes.
Okay, ready? With C. Look at this. Okay, shh. I'm going to do 6 times 1/3 first because I can't simplify this any. Cube root of 12 is not going to help me too much. So I'm going to do 6 times 1/3. This is going to be negative 12 over 5 to the power of, what's 6 over 3? 2. Right on. So what's negative 12 squared? Anybody know that? 144. Good. What's 5 squared? 25. Guess what? A negative, when you square it, becomes positive, so this answer is positive. And can we simplify this any? Nope. Done. Okay, I got time, so I'll do another one. D. 0.16. Watch this. It's a common base. I simply subtract the exponents. 3 over 4 minus 1 over 4. 0.16. That is 2 over 4, which is 0.16 to the 1/2, which is the square root of 0.16, which is 0. What's the square root of 16? Get fourthed.
Yeah.
I'm fourth. You with fourth to go into the fourth club. All right. Is that good? Okay, the rest of the review is due on the test day. Remember, you have a quiz tomorrow. Awesome possum. Hey, bell hasn't rang yet. Don't leave. See ya. Okay, relax, relax. Just have a seat. Wait for the bell. Yes, I'll show you the riddle.